All right, lesson 6, interpreting the standard deviation. Today we're going to look at how to calculate the standard deviation using a graphing calculator. Let's start, however, by remembering how to do it by hand. If for some reason you are doing this lesson at home and you do not have a graphing calculator, remember you can always do this lesson by hand. So our warm-up for this lesson is to do the standard deviation by hand. And then we're going to use the exact same problem and do it by graphic calculator. So there are 6 steps to do this problem by hand. We're going to start off first by finding the mean. So we're going to add up the numbers and divide by the amount of numbers. So I'm adding them all up. Don't forget your decimals. And my total comes out to 551.8. And divided by 8. And that comes out to 68.97. And I should have given myself some room here because I'm going to want to make a table out of this information to do the next 2 steps. So I'm going to make it easy on myself and I'm going to round this number to the nearest whole number. Let's just make this number 69. Okay, so that's always our first step, finding the mean. The next 2 steps are much easier to do in a table format. Next one we want to do is our deviations from the mean, where we want to take our data values and subtract the mean. And then after that we want to take those answers and we want to square them. Okay, so I'm going to take every single one of my numbers here and I'm going to subtract 69 from them. First answer is -2. And -1.8. Okay, this is step 2. Step 3 is to take all those answers and square them. Remember, negative numbers must be in parentheses. First answer I'm going to get is 4. Next step, the fourth step, is to add all those answers up. I get 17.64. The next step, I want to divide by n minus 1. That would be 1 less than the total. If I divided by 8 up here, then I'm going to be divided by 7 down here. So it's 17.64 divided by 7. That's 1 less than what I divided by previously. And I'm getting 2.52. And the last step is to square root that number. And that is my standard deviation. Remember, to square root, you need the second key and the x squared key. And I got 1.58. And that's my standard deviation. That's a pretty small standard deviation, about 1.5 away from the mean, which the mean was 68.9 or approximately 69. Okay, so that answer is pretty small. Okay, these were heights of men. So if the average height of a man is 69, you can count on that height within about 1.5 inches. Okay, so now let's see what we get using our graphing calculator. So first thing I want to do is I want to clear my calculator. That's not on here. So remember to clear our calculator. Second plus 7, 1, 2. Okay, so first thing we want to do is we want to hit the stat key. And then we want to push enter. And you're going to have some lists. If there were numbers in the list, we would want to scroll to the top of the list and push clear, followed by enter. Now, I didn't have anything there, but that's what I would want to do. In list 1, I want to type the data values and then push enter after each number. So to do that, go back and look at my list here on my warm-up. So I'm going to enter in each of these numbers. So 67, enter. 70.9, 67.6, 69.8, 69.7, 70.9, and two more, 68.7, and the last one, 67.2. Okay, then I want to press number 4, second and. Okay, second and mode, which is quit, and go back to your main screen. Then I want to push stat and calc. And I want to scroll over to calc up here at the top of the screen. And I want to select one variable statistics, which is number 1. It's already highlighted. And push enter. Now on your screen, I think there might be a little bit more. I'm going to push enter, and it's going to give me a whole bunch of statistics. When you see X bar, let me scroll for a second here. Okay, so here's my calculator screen. When you see X bar, that's the X with the line over top of it, that is your mean. And when you see the S with the X, this one right here, that's your standard deviation. Okay, so let's go back and look at what, hang on 1 second. Okay, so let's go back and compare with what we got by hand. So here's what I got by hand. So I came up with a mean of 68.95, and that matches what the calculator came up with. And I came up with a standard deviation, that's the final answer down here, of 1.58, and that's actually what the calculator came up with also, 1.58. So those numbers all match. So I did pretty good doing it by hand. Okay, so coming over here, I just did this whole problem. Here's my set of men. And I came out with the mean of the standard deviation from my calculator. So the mean came out to, one more time, I'm going to copy that over here. The mean came out to, oopsie, picked up my pen. Mean came out to 68.95. This is on my calculator. And the standard deviation is that one with the SX. That's 1.58. And that's the same numbers that I came up with using by hand. So both methods work. And when we take our test next week, you can decide which method you prefer to use. Okay, so let's do another one now by calculator. Okay, so the first thing that I want to do is I want to push the stat key and enter. What we're going to do is we're going to edit a list. And this time I already do have numbers in my list, so I'm going to go scroll to the top, and I push clear and enter. Oops, clear and enter, and all my numbers go away. So I'm going to enter in the height of these 9 women. So put them in one at a time. Push enter after each one of them. The next one hiding behind my calculator is, so there's 70.3 and 67.6. Oops. If you ever get an error like this and it says quit or go to is option number 2, you want to choose option number 2, and it's going to go to what the calculator did not understand that you entered. Oh, look at that. I tried entering in a number that has 2 decimals. I must not have put enter in between my 2 numbers. So I'm going to clear this out and start again. So it was after my 66 I made a mistake. So 70.3, enter. And 67.6, enter. Okay, so I entered 9 numbers in. If you notice that on the bottom of the calculator it says L110, so that means it's waiting for number 10 to come in. And that's how I knew that I entered 9 numbers. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, yeah, 9 numbers.
Staff, please excuse the question. Mrs. Langham, please come to the main office. Mrs. Langham, please come to the main office. Thank you.
Okay, now I'm going to have the calculator calculate the mean and the standard deviation. So I'm going to quit out of this, so second in mode. And I'm going to go into, hit the stat key again, and go over to calc. And I'm going to hit number 1, well, I want number 1 to be highlighted, the 1 variable statistics, and hit enter, and enter again, and there I get all this data. And the 2 things that I'm looking for are the X, we call it X bar, the X with the line at the top of it. That's the mean, the X bar. And then I'll be also looking for the S with the X. And the X bar is the mean, and that's it's 68.28. So that's the average height of the women, the mean height of the women. And then the S sub X is the standard deviation. So that's this one. And that's 1.57. So that's the standard deviation of the women. So the women came out to be a little bit shorter than the men, and their standard deviation is also a little bit shorter than the guys. Okay, exploratory challenge exercises 2 through 5. It says a group of people attend a talk at a conference. At the end of the talk, 10 of the attendees were given a questionnaire that consisted of 4 questions. The questions were optional. So it was possible that some attendees might answer none of the questions, while others might answer 1, 2, 3, or 4 of the questions. So the possible number of questions answered are 0, 1, 2, 3, and 4. Okay, so that's what our dot plot is showing, the number of questions answered. We're going to use our calculator again, and we're going to find the mean and the standard deviation of the data set. Okay, so once again, we're going to enter in our numbers. So the first thing I want to do is I want to go to stat. And number 1, edit, is already highlighted. And I want to get rid of the numbers that I already entered. So I go to the top up here and push clear and enter and get rid of my numbers. So for every dot, that represents a number. So I want to enter in all of those numbers. So I'm going to enter 0. And then for 1, I'm going to enter 1 twice, because there's 2 dots there. Then I'm going to enter in 4 2s. So 2, 2, 2, and 1 more 2. So that's my 4 2s. For 3, I'm going to enter 2 3s. And 1 4. Okay, so I've entered in all my numbers. Once you enter your numbers in, you're ready to go back to your main screen, so second and mode. And then you go back into stat and go over to calc, because now we're ready to calculate the mean and the standard deviation. So I'll go over to calc. And we want option number 1 again, the one variable statistics. The reason why we're using one variable statistic is because we only entered in one list of data. In the future, we'll do 2 variable statistics when we enter in 2 lists of data. Okay, so here's our results. And again, the two that we're going to use is the X bar, that stands for the mean, and the SX stands for standard deviation. So the X bar is 2, so the mean came out to 2. Which isn't surprising because this is a symmetric list of data, and the mean, the median, and the mode are all going to be in the middle there. And the standard deviation, the SX, is 1.15. It says, suppose the dot plot looked like this. What's true about everything there? Exactly the same amount of numbers everywhere. It says, use your calculator to find the mean and the standard deviation. So that one was symmetric. This one, everything is exactly the same thing. So let's see what happens with this set of data. Okay, so again, going in, stat, over to calculate, or excuse me, stay on edit. Number 1, edit, clear my list, I go to the top, push clear. Okay, and I'm putting 2 of everything in. So 0, 0, 1, 1, 2, 2, 3, 3, and 4, 4. Okay, quit and go back to the main screen, and then go back in stat, but over to calculate. And I want number 1, and here's my data this time. So remember that the size of the standard deviation is related to the size of the deviations from the mean. Explain why the standard deviation of this distribution is greater than the standard deviation in exercise 2. Okay, so the standard deviation in this case, oops, wrong one. This one came out to 1.45. Oh, hang on. Our mean came out to 2, and our standard deviation came out to 1.49. So the mean in this one is 1.4 versus the last one was 1.1. So the standard deviation stands for how far away things are from the mean. How come this one has a bigger standard deviation? The one down here has a bigger standard deviation than this one. Standard deviation is how far the numbers are from the mean. Well, in this case, the mean is right in the middle. And look at where all the numbers are stacked. Most of the numbers are in the middle. 4 of the numbers are in the middle. Whereas here, the numbers are evenly distributed throughout all of the numbers. There's only 2 right in the middle. You've got more numbers down here on the ends. You got 2 numbers down on the end, whereas up here you only had 1 number on each end. So you had more numbers closer to the middle on the first graph, so that's why the second graph has a bigger standard deviation, because you have more numbers further away from the middle where the mean is at. Okay, let's see if I can put that in writing. It says, remember that the size of the standard deviation is related to the size of the deviations, or how far away they are from the mean. Explain why the deviations of the distribution is greater in number 2. So in number 2, the numbers are further away from the mean, which is in the middle. Than they are in number 1. Hope that makes sense. If it doesn't, then feel free when you're watching the video, if you're in class, to call me over and help ask me to explain. If you're at home, feel free to ask me when you come to class the next day. Okay, last one. It says, suppose that all 10 people questioned answered all 4 questions on the questionnaire. Okay, so that means that we have 10 people all stacked up answering all 4 questions. Okay, so if we have 10 people, right, 10 people that answered all 4 questions, then all of their dots are going to be down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that's what the dot plot's going to look like. Next question says, what is the mean number of questions answered? Well, if all of the numbers, and we should be able to do this without any calculating, if all of the numbers are going to add up and be exactly the same, then the mean is going to be 4. And the standard deviation, we shouldn't have to do any work on that. Standard deviation, how far are all those numbers going to be from 4? It's going to be 0. All of those numbers they're nowhere away from the mean. They're all on the same exact spot. Okay, this one says, draw a dot plot of distribution of the possible data points where the largest possible standard deviation. So I want you guys to do this one. It says draw the dot plot of the distribution of possible data points. So this is actually the smallest standard deviation. Think about what it would look like to have the largest possible standard deviation. And when you get done with that, I want you to show it to me in class and let me tell you if you were right or wrong. Okay, and that's it for today's lesson. Make sure you check the answer out for that one. I showed you the smallest. You think about what would be the largest possible standard deviation.